In this video, we're going to graph some rational functions. I would characterize this video as moderate difficulty rational functions. This is geared toward my pre-calculus students. If you are looking to graph rational functions but need a bit more in the way of introduction, you can check out MrB Explains 8-3 and MrB Explains 8-4, which will explain to you how to graph these. This year, though, we're introducing two new concepts, so I'm going to be flying through the introductory stuff. The first one is oblique asymptotes, which I usually call slant asymptotes, because slant is an easier word than oblique. But those will be new. And then also we're going to talk about removable discontinuities, which is something we're going to see in pre-calculus that we didn't see in Algebra 2. My first example here has neither of those. So it's basically a review from last year. A of x equals x plus 1 over x squared minus 4. The first thing I'm going to do, for reasons that will become apparent, is factor. Now the top is already linear and doesn't need to be factored, but the bottom is a difference of two squares, so that's x minus 2 times x plus 2. I make a list of 4 things to look for anytime I'm about to graph a rational function: vertical asymptote, horizontal asymptote, x-intercept, and y-intercept. Those 4 are relatively easy to find, and they make a great place to start. So vertical asymptotes occur where the bottom is 0, which in this case are at plus and minus 2. The horizontal asymptote is really an end behavior question. So we compare the degree on top to the degree on the bottom. Since the bottom has the higher degree, the bottom of the fraction will get bigger faster, which means the function will approach 0 as x increases. So my horizontal asymptote will be y equals 0. The x-intercept will occur where the top is equal to 0, which in this case will be at negative 1. And the y-intercept, to find that I'll stick in 0 for all the x's, which if those become 0, I get negative 1/4 for my y-intercept. Come over here and plot all these on my graph. I have vertical asymptotes at positive 2 and negative 2, although I'm drawing them in the reverse order from that. Negative 2 and positive 2 equals positive 2. I have a horizontal asymptote at y equals 0. You are allowed to cross your horizontal asymptote in the middle. It's an end behavior question. It only matters on the ends, not in the middle. X-intercept at negative 1, y-intercept at negative 1/4. So here in the middle, I can see how this has to be going. It has to be going down already. Before it reaches this asymptote, it has to turn, because you're not allowed to cross the vertical asymptote. So you might think about going up, but there's no more x-intercepts over here, so the graph can't turn up, it has to turn down. Connect the dots here. Similarly, since we're crossing here, this has a multiplicity of 1, so it's a sign change. I have to cross to the other side, and I'll have to continue up because there's no more x-intercepts. So it gives me the shape in the middle. Because the bottom, each shape has a multiplicity of 1, we are expecting a sign change. If you want, you can stick in x values like 3 or 4 to find actual points on the graph, but if you're just sketching a graph, you can go right from the asymptote, from the vertical asymptote to your horizontal asymptote, and I'm not really worried about how high or low it is. You can always find more points, but if you're trying to graph it that precisely, you should be using an electronic tool anyway. On the left, then we're going to have the same thing. This asymptote has a multiplicity of 1. It's odd, so it's a sign change. It's going to switch from positive to negative. So this one's going to come up from underneath. And again, you could find points, but for sketches, I'm just looking for a basic shape. So vertical asymptote, horizontal asymptote, x and y-intercept, drawing the shapes is necessary. Example B is somewhat more challenging. So as I go to factor this, I know the bottom, once again linear. The top, to factor this I would need 2 numbers that multiply to negative 8 that add to positive 1. But 8's 1 and 8 are 2 and 4, and neither of those is going to add to positive 1. Which means my top is at least irrational and possibly imaginary, the zeros. So I'm going to use the quadratic formula, which tells me opposite of B plus or minus the square root of b squared minus 4ac all over 2a. So that's 1 plus 32, definitely irrational, but it is real. So my x-intercepts are at 1 plus or minus the square root of 33 over 2. Square root of 33 is a little under 6, so that'll be, let's see, it's a little less than 6. So negative 1 plus 6 would be 5. So this is a little less than 2.5. A little less than 2.5. And then the other one, negative 1 minus 6 would be negative 7. It's going to be a little bit to the right of negative 3.5. Okay. So there, I'm going to approximate them. You could get a decimal from your calculator as well. You don't have to do those by hand. The vertical asymptote is going to be at negative 3. The horizontal asymptote, as I look for it, the top has a higher degree than the bottom, so there is no horizontal asymptote. This graph is going to approach infinity, which last year we would have left it at that. But when the degree on top is exactly 1 higher than the degree on the bottom, this is the situation that produces the slant asymptote, the oblique asymptote. So we're going to come back around to that. Lastly, I need y-intercept, which is going to be negative 8/3. Okay, I need to find my slant asymptote, and then I can go to the graph. So to do this, you're actually going to divide the functions. The quotient after you divide is what's going to give you your slant asymptote. Since the bottom is linear, x minus k, x minus negative 3, I can use synthetic division to divide, but if not, I would have to use long division. So that's 1, negative 3, negative 2, positive 6, negative 2. So this is x minus 2 minus 2 over x plus 3. Now as x approaches infinity, this will approach x minus 2 because the x on the bottom there will be getting bigger and this fraction will approach 0. So the further you get toward infinity, the less this fraction is going to be. It becomes unimportant, and that's how you get a slant asymptote at x minus 2. So I'm going to start with my asymptotes. I have one at negative 3 over here, and my slant asymptote, which is my end behavior, is at x minus 2, which is a line with slope 1 that starts at negative 2. Now, just like the horizontal asymptote, this is an end behavior consideration. So in the middle, I don't have to be anywhere near this line, but I'm going to start and end along this horizontal or this slant line. So let's see, vertical asymptote, I have a slant asymptote. My zeros are around 2.5. And negative 3.5. Just to the right. Okay. And then my y-intercept, negative 8/3 is 2 2/3. 3, 4, 6, 7, 8/3. All right. Dealing with the left side, the right side here first, I'm going to be coming up off this asymptote. Since I have to get down here and there's no x-intercepts, I have to come up from underneath. I'm going to hit these 2 points, and I'm going to end asymptotic with this slant line. So I'm going to come up from here, I'm going to go through my 2 points, and end with a slant asymptote right up there. On the other side then, since the bottom has a multiplicity of just 1, sign change, I'm going to come from the top. I have to end on this asymptote, so this is just from the slant asymptote up through my point to my vertical asymptote. Like so. So this graph has a slant asymptote, and that's a new. Oblique is what your book uses, or my book, the book I'm using in this class. Okay, my next example is the one with the removable discontinuity, just to warn you. The top we can factor. I might need a new piece of paper. So the top, we factor out the 2, we get x squared minus 9, which is the difference of squares. So that's going to be 2 times x minus 3 times x plus 3. And the bottom is just x minus 3, x plus 2. So when I work out my vertical asymptotes, it looks like we're going to have positive 3 and negative 2. The horizontal asymptote, the degree on top and bottom are the same, so I divide their coefficients, and I get y equals 2. The x-intercept list looks like it's going to be positive 3 and negative 3. And here's where we notice our problem. Positive 3 is on both lists. It cannot be both of these at the same time. That's the situation where we're actually going to find it's a removable discontinuity rather than a vertical asymptote or a 0. I will find my y-intercept and circle back to that though. Negative 18 divided by negative 6 is positive 3. Well, that's a lot of 3's. So when you have a common factor on top and bottom, if they have the same multiplicity, they will cancel out anywhere you have a point on this graph. But you're still not allowed to stick in 3, because even though this really cancels everywhere, at 3, you're still trying to divide by 3. So this is what produces what we call a removable discontinuity. It's one point missing from your graph. Continuity. So the graph is going to look smooth, and if you graph this on a calculator or some sort of electronic tool, it's likely you won't even be able to see the point that's missing, because they just connect the dots. So we need to watch out for these. Now in this situation, if you want to find out where the removable discontinuity is, you have the x value, it's at 3. To find the y, go ahead and reduce your function. X plus 3 over x plus 2, and stick in the value. So I'm going to stick 3 in here, and that gives me 2 times 6, which is 12 fifths. Now this will not be a point on our graph, it will be a point missing from our graph. But we need to be able to draw it as an open circle, because we need to be prepared for it. The graph will go through there, it's just there'll be 1 point missing. So I have a vertical asymptote at negative 2. I have a removable discontinuity at 3 12 fifths, which is 2 and 2 fifths, open circle. That's my removable discontinuity. Y-intercept is 3. See how that's working. Horizontal asymptote at 2. So come down off of here, through and over. And oh, my other x-intercept at negative 3 helps me shape this part of the graph. I hear students coming, so I'm out of time. But there's my third graph. Hopefully that's enough to get you started.